Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. You're with me, Mazlina Ismail, and you're watching www.tvIKIM.my. I have a special interview for you, all of you watching right now, and I have these two gentlemen to talk about Astrolabe. But before that, I would share with you what Wikipedia described Astrolabe as. An astrolabe, or a star taker, is an elaborate inclinometer historically used by astronomers, navigators, and astrologers. Its many uses include locating and predicting the positions of the sun, moon, planets, and stars, determining local time given local latitude, and vice versa. Surveying, triangulation, and to cast horoscopes. It was used in classical antiquity and the Islamic Golden Age, the European Middle Ages, and Renaissance for all these purposes. In the Islamic world, it was also used to calculate the Qibla and to find the time for Salah and prayers. I'm happy to introduce these two gentlemen with me today, none other but Dr. Robert H. Van Kent and Mr. Wilfred de Graaf, who are here for the seminar and workshop on the Astrolabe, its history and application, organized by the KC's UTM Kuala Lumpur. Good afternoon.
Good afternoon.
How are you, Doctor?
Fine, thank you very much.
Alhamdulillah. And both of you are here for the seminar and workshop on the Astrolabe, its history and application, organized by KC's UTM.
Yes.
Right. And mentioning the Astrolabe, this afternoon we'd like to inquire so much from Dr. and Mr. Wilfred on what is an astrolabe and how does it work. Perhaps Doctor would like to begin that.
Okay.
Yes.
Well, an astrolabe is an astronomical instrument which was used in the Muslim period, in the Middle Ages, for many centuries. And it's an instrument which you can use for telling the time, which of course is very important. I mean, for prayer times, for instance, you have to determine that. Well, an astrolabe can help in determining the time. You can also use it the other way around if you want to know how the heavens is oriented with respect to the horizon. You can set to the instrument a certain hour, a certain day, a certain month in the year, and it will tell you how the heavens are oriented with respect to the horizon. It's a very ancient instrument. It was already used by Greek astronomers. Muslim astronomers later learned about this instrument. They modified it, added new functions to the instrument, and even later on, European astronomers also became interested in the astrolabe, and they copied from Muslim astronomers. So it's an instrument which passes through different cultures. Each culture adds new functions to it, and it was used at least in Europe until the 17th, 18th century, and in the Muslim world it was even used until the 19th century. So it really has a very fascinating history.
Does it tell time exactly as in today's clock that we have?
Well, not so exactly, of course, but I mean, in the Middle Ages, people did not need the time so exactly. But it was accurate enough for that period.
I see. But how does one use it, Doctor?
Well, mathematically, it's not a simple instrument. My colleague can perhaps say later a little bit more about the mathematical background, but it was very cleverly made. It has different parts. Some parts you rotate with respect to each other. You need that if you have to set it to the right time, the right date, etc. But that's also part of the workshop, of course. That's what we are going to explain in the workshop, how the different components of the astrolabe and how to use it. I mean, you have to really do it with your hands. I mean, you can read about an astrolabe in a book or on the internet, but you really have to use the instrument. And for that, we'll be using a paper model because real astrolabes are priceless objects nowadays. So, but with paper astrolabes, you can explain in the same way how it actually works. But that's something we'll do in the workshop.
I wish we have one that we could, show to our audience how astrolabe actually looks like. But
well, my colleague has
I have the cardboard models with.
He has a model with him, so we can perhaps.
Show it later.
Yes.
Later,
yeah.
Back in those days, all public is commonly used astrolabe to tell time, or is it certain people?
Yes, well, I mean, as I said, it's mathematically a sophisticated, complicated instrument, so you had to know how to use it. And it was also a very pricey instrument. I mean, it was made out of brass. To manufacture an astrolabe took many weeks for an experienced craftsman. So, I mean, it was only the people who could afford such an instrument who had such an instrument. But you must think about astronomers, about astrologers, and you must think about people who are associated with the mosque, who have to determine the prayer times. And such people had an astrolabe, or at least had access to an astrolabe.
Okay, it says that the astrolabe used for the Islamic and Western civilizations.
Yes, that's
How
true.
does it tell time for prayer time for Muslims those days?
Well, I mean, on the astrolabe you can put special lines which tell you when the sun has a particular altitude above the horizon, that then, for instance, it's time for the midday prayer or it's time for the afternoon prayer, and you just have to set the instrument at in the right way. You also have to account for your latitude, because the way the sun is in the sky depends on where you are on Earth. I mean, in Malaysia you're much closer to the equator than, for instance, in Baghdad or in Cairo. But the astrolabe had a special way of compensating for that.
Okay, do you remember who actually invented this tool?
No, unfortunately we don't know. We know that Greek astronomers already used this instrument, but some people claim that perhaps Ptolemy, a very famous Greek astronomer who lived around 150 AD in Alexandria, but it was probably already known before him.
Seeing that you have a special workshop on astrolabe, Doctor, perhaps Mr. de Graaf wants to answer this. What is so special about astrolabe compared to other scientific instruments in the history of science?
Well, the astrolabe was one of the most used instruments in the Islamic civilization and as well in Europe from the 11th century on, when there was this transmission from knowledge from the Islamic world to Europe.
How long was it used?
Yeah, it was
before?
used, well, as Dr. von Gent already explained, its principles were known in Greek time. And this knowledge was preserved by the people of the Islamic world. They translated it into Arabic and made the first real one, astrolabe, that survived till today.
Yes.
And they also added some new features. So they put some new mathematics into the model. So they made it better, the astrolabe. And many of these astrolabes have survived till today, and you can find them in various museums.
Now that the invention of clock and digital clock, it has been abandoned since.
Yeah.
Yeah. So why do you think that the younger generations, today's generation, needs to find out and to learn about astrolabe?
Well, in my experience, I've been given lots of workshops on the astrolabe before in many other countries, like Turkey, Iran, and even Saudi Arabia. And the astrolabe is really a part of the history of the Islamic world.
Okay.
And I've noticed that lots of young people in the Middle East and in the broader Islamic world are completely unaware of the existence of the astrolabe. So I've been to Saudi Arabia to a university in there, and we had this astrolabe workshop for the students, and none of them had ever heard of the astrolabe before. So they were very much interested in engineering and in football, and they became, in the end, after the workshop, they became very excited about their history. They had the feeling they really had learned something about themselves. So it was good for their self-esteem as well. So they appreciated their own history more.
You said that in the history, especially in Islamic civilization, that astrolabe was used quite commonly.
Yeah, for the
those
prayer
days.
times.
Yeah.
Because in Islamic religion, of course, it's very important to know the exact time of the 5 prayers
That's right.
of
So,
the day.
yes, what did the production and the use of the astrolabe indicate about the level of scientific knowledge and technological mastery in the Islamic civilization back then? By using astrolabe, what are you? How do you see that the scientific knowledge of those people at that time, is it as the same par as the Greek, or even much more developed than that?
It's well, the Greeks, they knew the principles behind astrolabe, but the real astrolabe didn't survive from that time. So the mathematical principle of an astrolabe is a projection method called stereographic projection. And well, this theory, it survives from the Greek time. And the Arabs, or the people from the Islamic world, used that theory to construct their own astrolabes. And they added some new features, like lines of equal direction. They didn't exist in the Greek, in the manuscripts from the Greek time that survived till now, that we know of. So that's a contribution of Islamic scholars.
Okay, Doctor, what impact does the introduction of the astrolabe from the Islamic civilization, as de Graaf said, has on the development of science and technology in the West later on?
Well, I mean, as I already mentioned, European astronomers at a certain point began to realize that Islamic astronomy was on a higher level than their astronomy, and the astrolabe was one of these instruments that they were very much interested in. They were, of course, interested in other things as well, I mean, other texts as well, but especially the astrolabe became very popular also in Europe. I mean, even a poet, an English poet, Chaucer, he even wrote a book on the astrolabe. So just to give you an idea that, and you see that also in the centuries which follow. The astrolabe was really a very popular instrument. It was also mathematically a rather sophisticated instrument, so it showed how high the development of Muslim astronomy and mathematics was. It also showed you the skill of the maker, because the astrolabe has a lot of lines and circles on it, and it all has to fit, all has to be drawn very carefully, because otherwise the instrument wouldn't function. So it was a bit of a marriage of knowledge and technology, because the instrument maker himself had to be very skilled to make an actually good working astrolabe. And you can see that in the astrolabes which are still preserved in collections all around the world.
So what attractions do the astrolabe hold for you as a mathematician?
Well, again, the story which it tells. I mean, you can read books, of course, you can read manuscripts, but you can also, in the instruments, read a story. And astrolabe tells you a very fascinating story, how astronomy passes from the Greeks to the Muslims, from the Muslims to Europe, and from Europe to the modern period. And as again, it is also a very skillfully crafted instrument. It tells you also about the development of technology. So it has many stories to tell, but you have to look at the instrument, of course, and it helps if you understand how it works. Otherwise, it's just a collection of things which rotate with respect to each other.
As we mentioned off air just now, that to tell time those days takes really a lot of effort to do simple things, but with the invention of sophisticated gadget these days, I think that the youth or today's generation are not really keen into going for mathematical or science studies.
Well, that's a pity.
What do you think of that?
Yeah, I think that's a pity, because there's a lot you can learn from that, and it's part of your heritage, which I think everybody who has an interest in knowledge should know about. And just one other thing, which perhaps is interesting for your viewers. Have you ever wondered on your watch why the numbers go this way?
Yeah, clockwise.
Clockwise, indeed. Well, it's because the astrolabe was before the clock, and on the astrolabe, the hours also go this way.
Okay.
So when the first clocks were made, and they had to design a dial, they just copied it from the astrolabe. I mean, you could also make a watch going this way.
Yeah.
In novelty shops, you can even buy such watches.
Yes.
There's absolutely no reason why it has to go this way.
Okay.
But it's the same way that the astrolabe also does it. So that's one still lasting effect of the astrolabe on modern clocks.
This is a new information for me today. And Mr. de Graaf, how do you think the study of astrolabe could incorporate it in the syllabus of schools and universities today? Do you think it's important that...
Yeah, it can be incorporated as not an obligatory subject, but for instance in high school it can be can be done in the physics course, I think, as an optional subject. So, for instance, this workshop, you provide the students with a paper model of the astrolabe, and it takes only 2 lessons, I think, to learn them about the functions and the use of the astrolabe. And they learn a lot, I think, about the movements of sun and stars, and also about the history, of course, of science. So they learn a lot in a limited amount of time.
Yes.
So it can be incorporated as an optional subject in high school easily within the physics course, I think.
Talking about education, what attracted your interest into taking mathematics or science as major?
Yeah, well, when I was in high school, it was my favorite subject, mathematics. And from early on, I knew that I wanted to study something related to mathematics.
Okay.
And in the end, I just chose for just mathematics in combination with physics. So I studied at Utrecht University in the Netherlands, and they in that university you could study mathematics and physics as well together at the same time. So I did that. But my preference has always been, my favorite subject has always been mathematics.
Okay. To both of you, can we say that the approach of teaching science and mathematics plays an important role on why students or younger generations not opting to take science and mathematics as options for tertiary education? For you yourself, Doctor?
Well, I mean, I have more or less the same background as Mr. Wilfried de Graaf. When I was a high school student, I was also very much interested in mathematics, physics, chemistry, even more in astronomy, because I actually I actually did an astronomy education at university, the same university as Utrecht, actually.
Yeah.
But later on, when I finished my astronomy studies, I became more and more interested in the history of astronomy. And well, from the history of astronomy, you look at the astronomy of different cultures, not only European cultures, but the cultures before Europe. So you then get interested in Muslim astronomy, Greek astronomy, Babylonian astronomy. So that's more or less my background in this whole area of research.
Yeah, but what specifically attracted you to learn about maths and science? Is it the approach that the teachers use during the school time?
I think it also depends on your teacher. I mean, some teachers can be very inspiring, and I was lucky, I think, that I had some teachers who really inspired me. And well, I had, of course, also the opportunity to visit foreign countries at that time, because my parents lived abroad.
I see.
I had my education in the Netherlands, but I was allowed during the summer and the winter holidays to visit my parents abroad. Some of these countries were Muslim countries, so I really had at a very young age, well, some kind of introduction to Muslim cultures. So, but well, I mean, why some people are attracted to science and other people are not?
Yeah.
It depends on many factors. I think it's not only your upbringing, but also with kind of people you get into contact with. And I was lucky; I had a few teachers who were interested in this. I also had a very close friend at school who also had the same interest. So that all.
Put together.
Put that together.
That's what brings you here today.
Yes, exactly.
Alhamdulillah. And was it the same case for you, Mr. de Graaf, that the teachers actually?
Yeah, teachers are very important in high school, I think. But my mathematics teacher wasn't particularly inspiring, so it came more out of myself than in the case of Dr. van Gent, I think.
Okay.
But I think the situation differs greatly between countries. So I have been many times to Iran, for example, and many students chose to study sciences or technology, much more than in the Netherlands, in which people have a tendency to prefer humanities or law.
Right.
So the situation differs by country, I think.
Okay. Now that we have more advanced and sophisticated technologies, what do you think? What is the importance of learning Astrolabe now, Mr. de Graaf?
I think the Astrolabe is really a building block of science. So in order to understand modern science, you need to understand the development of science, the foundations of it. So in that way, it is important to understand the whole structure of science as it is nowadays.
Okay, thank you. My final questions. You said you both of you have been traveling to Muslim countries. What do you think about Muslims these days and their interest of learning science and mathematics in general?
I think it's very good.
Yeah.
I mean, Muslims should be aware of their history. I mean, of course, there are problems. There's the modern society you have to live with, and which has all its own questions and problems. But it's also important that you know your past. I mean, there was a historian, I think, who said, "A country without a history has no future." So I think it's very good that young Muslim people are interested in things like that, even if they perhaps don't have any practical use nowadays, but it will still help how society, how science developed.
And you, Mr. de Graaf?
Yeah, for instance, in mathematics, it's you see many people working in mathematics: poor people, rich people, boys, girls, Christians, Jews, Muslims, atheists, everyone, and they are just mathematicians, and they all work together. They don't really care about backgrounds of people.
Yeah.
So it's not that important anymore to distinguish between Muslim people or Christian people or people from Nigeria or Russia. They all work together on one subject, and they have only one goal to understand mathematics. But that's the case for mathematics, for example.
Okay. With that, we've come to the end of our talk show today. We wish you all the best for the workshops, and we hope that our future generations will be more interested to learn a lot about history of science for the benefits of the future.
Thank you
very much, gentlemen.
Thank you for inviting.
Thank you to both of you, gentlemen, Dr. Van Gen and Mr. de Graaf, for a very significant sharing on history of Astrolabe and also the importance of learning science and mathematics. And with that, we come to the end of the show for a special talk with these two gentlemen today. Until soon, Assalamu alaikum.